Let me bring out the chat if I can manage. Damn it. I streamed 1 week ago and I already forgot how you do this. How do I get the chat open? This is the problem, not having a clue what you're doing and then starting a stream. Alright, there we go. Yo, what's up, guys? Yeah, we'll see. I learned about sort of recommender systems a while ago, but let me see. But I forgot all about it. Your voice changed a lot already. Is it like distorted in some way, or does it sound okay? And what's the delay like? Let me try. Wait, sign into chat. Okay. All right. Tell me when you hear this, and we'll see what the delay is. Where's the chat? All right, whatever. I'll just do this. I have no idea how I get the chat. I'll just do this. Are you serious? Maybe it's the browser or something. Oh, there we go. Now it's there. All right. Yeah, me too. To be honest, this is not something I'm that knowledgeable about, so we'll just figure it out. But my idea is like, I know. So when I learned about this a while ago, it was basically, I did the basics of a content, what is it called? Content-based versus collaborative or something. And I was thinking of doing kind of we can try to understand that there was a neural collaborative paper or something. That's from 2017, so it was a while ago, but apparently it was pretty impactful, and it should be pretty easy to understand, I hope. But we will see. So how are you guys doing? I know that Abhishek Thakur, he made some video a while ago of some recommender system. I don't know, I watched a bit of it, and I guess this is based on it's based on this paper probably. Maybe we can take a look at him. Movie lens data set, we can probably take a look at that. Classic movie lens data set. Have you guys done a lot of work in like recommender systems? Anyone got any recommendations as to what to start with? Apparently this is a very influential paper, so this is hopefully a good place to start. But let me know if you have better ideas. That's nice that you got a 30-point score on your project. Alright, let's check this. I know also I did maybe we can just, I looked at the machine learning specialization a while ago. Maybe we can take a look at it just to get some refresh, because it was a long time ago at this on recommender systems. So I've kind of forgotten a bit. Yeah, me too, Balram. Yeah. If you got any recommendations, guys, let me know, okay? Alright, what was it? Collaborative filtering, content filtering.
Welcome to this second to last week.
I just feel like every time I hear Andrewing, it's like, I just know it's gonna be good, you know? This is basically where I start with everything I learn. I'm like, let's go to Andrew Ng so that you feel safe, you feel at home, you feel like things are well in the world, and then when you have understood his stuff, you go to this mess. And well, I mean, this paper is probably pretty good, but I mean, like, comparatively to Andrew Ng, this is difficult stuff, you know. So I feel you about them, but but we don't have to start there, you know. We can postpone this hard stuff.
Of the machine learning specialization. I'm really happy that together we're almost all the way to the finish line. What we'll do this week is discuss recommender systems. This is one of the topics that has received quite a bit of attention in academia, but the commercial impact and the actual number of practical use cases of recommender systems seems to me to be even vastly greater than the amount of attention it has received in academia. Every time you go to an online shopping website like Amazon or...
Wait, I'm blurry as fuck. What happened? What? Wait, is this how it looks like? Oh my god. What a noob streamer. God damn it. Is it like... I wonder what happened to my camera. Wow. Okay, we're back. What the fuck happened? What the fuck happened there? I just looked at myself and I saw it was like a green blob. Hopefully it's good now. I wonder how long it was that, like that.
a movie streaming sites like Netflix, or go to one of the apps or sites that do food delivery. Many of these sites will recommend things to you that they think you may want to buy, or movies they think you may want to watch, or restaurants that they think you may want to try out. And for many companies, a large fraction of sales is driven by their recommender systems. So today, for many companies, the economics or the value driven by recommender systems is very large. And so what we're doing this week is take a look at how they work. So with that, let's dive in and take a look at what is a recommender system. I'm going to use as a running example the application of predicting movies.
Akash, yeah, I'm using Mac. Do you face any problems while doing projects for data science? Well, wait, let me just, if I can move the chat so people can see as well. I think in the beginning, sort of when I bought the M1, I did. I think now it's pretty, I don't face that many problems. Although I would not use Mac for training any deep learning based models. Like I would not. And in fact, I got problems when I tried to use like MPS device for training, sort of the like the GPU version on Mac doesn't really work that well. So yeah, what I like my setup now is I like the user interface on Mac. I like moving around like this. I think it's pretty smooth. I like that the Mac is quiet. It's like, yeah, it's like it's nice, but for deep learning based stuff, I think Linux is king, and so that's why like my setup is I SSH into a Linux machine, and that's my setup. But for like simple projects and stuff, Mac is fine, but for training stuff, not so good. All right, I'll keep the, let's see, I'll keep the chat over here. All right, I'm happy to hear it. All right, let's see what they did. So, I mean, we want to have like a PyTorch, neural collaborative filtering, PyTorch, GitHub. If there's someone that's implemented it, we can just, oh, nice. They also use the movie lens dataset. Cool stuff. This was a lot of different files. Res and source. Data, utils, metrics, generalized matrix factorization model. Oh, I have to say that matrix factorization is already not even a technology of yesterday. It is a technology of last century. Well, I'm not that familiar with recommender systems, but it seems that a lot of things happen from this paper, maybe from using sort of deep learning based sort of neural networks.
Movie
But yeah, let's just
ratings.
refresh sort of how it
So,
works.
say you run a large movie streaming website, and your users have rated movies using 1 to 5 stars. And so, in a typical recommender system, you have a set of users here. We have 4 users: Alice, Bob, Carol, and Dave, which I've numbered users 1 through 4, as well as a set of movies: Love and Last, Romance Forever, Cute Puppies of Love, and then Non-Stop Car Chases and Swords vs. Karate. And what the users have done is rated these movies 1 to 5 stars. Or in fact, to make some of these examples a little bit easier, I'm actually going to let them rate the movies from 0 to 5 stars. So say Alice has rated that users. And even though I'm using movies in this example, the same logic or the same framework works for recommending anything from products a website might sell, to restaurants, to even which media articles, or social media articles.
I'm real curious, like how Netflix actually does their recommender system, how it works.
To show to a user that may be more interesting for them. The notation I'm going to use is I'm going to use NU to denote the number of users. So in this example, NU is equal to 4 because we have 4 users, and NM to denote the number of movies, or really the number of items.
But wait. Maybe I can't watch this on stream because it's like a paid course or whatever. I just realized.
So in this example,
but I think they're up on YouTube, so I think it
is
should be fine.
Equal to 5 because we have 5 movies. I'm going to set Rij to be equal to 1 if user J has rated movie I. So for example, user 1, that is Alice, 4. Notice.
All right, so wait, how does it? Using per item features. So this is like collaborative filtering, okay.
So let's take a look at how we can develop a recommender system if we had features of each item or features of each movie. So
let me just get an overview of this. So in recent years, deep neural networks have yielded immense success on speech recognition. However, the exploration of deep neural networks on recommender systems has received relatively less scrutiny. I just want to sort of skim it at first, and then we can get into a little bit more detail. All right, when it comes to model the key factor in collaborative filtering, the interaction between user and item features, they still resorted to matrix factorization and applied an inner product on the latent features of users and items. Okay, so we used some matrix factorization method previously, but then they want to replace the inner product with the neural architecture that can learn an arbitrary function from data, and they represent NCF, short for neural-based collaborative filtering. Okay, so that's the idea. All right, so we are gonna replace matrix factorization with some neural network. All right, introduction. This is an important problem. All right, the main contributions: we present the neural network architecture to model latent features of users and items, and devise a general framework based on neural networks. We show that MF, what is MF? Matrix factorization, can be interpreted as a specialization. Okay, so the neural based is more general, I guess. And then they perform experiments to show that it's effective. The name of the paper is Neural Collaborative Filtering. Let's see. Would you give some advice for people who want to understand and implement deep learning architectures from scratch? Thanks in advance. You know, I think this is like it's difficult. It's difficult for me as well, and I think it just requires a lot of patience and trying to sort of be able to stick through it, and not get too frustrated, and just sort of take one step at a time. So I would say first understand the paper, and by doing that, we do as we are doing now. We sort of first just get an overview, right? Nothing too difficult. Just sort of like I have no idea how this works now. This is completely, I don't know. So this is new. So now I just want to get familiar. First, how they do it before, like how they do it. What is matrix factorization, and like how does it actually get? How does it work in the recommender system, and how is that then replaced by the neural network? How does the architecture look like? Would it be difficult to how would it look like if we implemented this? These are sort of my thoughts right now. And then I'm thinking, all right, what does the data look like? And I think that's good to get some resource. Maybe like here, I go to Andrew Ng. I know he has some videos. It's good to get an introduction to the sort of the idea of the area, right? And then maybe check some other implementations. If there are people who have implemented it, why go through it? Like, there's very rarely that you have to implement the paper completely from scratch yourself. Usually there are, the authors publish GitHub code. You can look through the code and so on. So yeah, I don't know if that was helpful, but those are some of my thoughts on it. And yeah. Yeah, you can ask me about CycleGAN. It was a while since I did that one, but I can maybe try to help if you give me a question. All right, let's go back then. So let's see. So, all right, matrix factorization is a special case. How they show that. Let's see. So this is, I guess, no, it's not. Is this unsupervised? No, it's not, right? This is a supervised method because we have users and we have them rated the products or the movies. So we have here, we have one if interaction is observed, right? Because we don't have the ratings for each movie from the user. Right, and if it's one, it doesn't mean that it's actually, it's just that it exists a rating for it. All right, so then we have something like this, user item matrix. Don't really understand this. What is this I1 and stuff? Okay, this is an example that illustrates its limitation. Okay, all right, let's just skip that for now. Okay, so here's the figure. So wait, we have user latent vector. How does this work? Let's see. Okay, so wait, we have we have a database, I guess, of each user, I guess, and we're talking about a specific user, and then we have an embedding layer, sort of a representation of that user, some type of embedding, maybe what type of movies that user likes. So that would maybe be let's see, that would maybe be like if they like action movies or drama or whatever, like we can imagine. And then we do one for the item, so we have a specific movie and we sort of represent what we think this particular item is. So this movie is action, this movie is whatever. We put them together, right? So we just add those, concatenate, I guess, or some take the mean maybe or something. We run it through some some linear layers or something. We compute a score that is our prediction of how much user I likes or user J likes item I. So how much a particular user likes that movie, and then we compare it to the target, and then we train. That's my sort of thinking right now, just from this graph, but it might be wrong, so we'll see. Let's see. I made a recommender system using Create. Okay, I have not heard that. Maybe we can check what that is. Create. Simplifies the development of custom machine learning models. So is this like a wrapper built on top of something that makes it a bit easier? It has 11K stars, so it seems pretty popular. For a project, I should implement a cycle again that generates portraits starting from real faces, passing them a style. But one thing is not clear. Should I have a data set of only Van Gogh portraits, or is it okay to have other types of images within the data sets, for example landscapes? I actually don't remember how I did this. What do you mean style? So okay, you have like here we convert a zebra to a horse and vice versa. What is your input in this case would be a portrait image of and then you want it to be in a particular style? Wouldn't that be sort of neural style transfer or something? Input are real faces. Okay, so you have a real face and then you want the output to be sort of a style of that. You want the output to be a style of that, of a particular Okay, then I'm thinking, I'm wondering if is cycle GAN the best approach here? Maybe you would want to use something else that just adds a specific style to the image, because well, I guess I mean, here you see like you need to have both of them and go back and forth, I guess. Like in that case, you should have real faces there are in the style of Van Gogh, and then you go the other way around as well. Because here you have images of horses and you have images of zebras, and then you do back and forth between both of them, so you cycle. But it seems in your example, you only want to go one direction. You have a real face, you just want to input some style to that image, and so it's not really a cycle. You don't have images the other way around, it seems. So maybe then you want to do some type of neural style transfer thing. I don't know. I mean, this is a while ago. There are probably better things right now, but something like this where you would take sort of an input image, and then you would take a style that you wanted, and you would get something like this or like this, and you can sort of modify the strength of it.
So here's the same data set that we had previously, with the 4 users having rated some but not all of the 5 movies. What if we additionally have features of the movies? So here I've added 2 features, X1 and X2, that tell us how much each of these is a romance movie and how much each of these is
thanks,
an action.
Setu, for becoming a member. Welcome to the team, bro.
Movie. So for example, Love at Last is a very romantic movie, so this feature takes on 0.9, but it's not at all an action movie. So this feature takes on 0. But it turns out Non-Stop Car Chasers has just a little bit of romance in it, so it's 0.1, but it has a ton of action, so that feature takes on the value of 1.0. So you recall that I had used the notation NU to denote the number of users, which is 4, and M to denote the number of movies, which is 5. I'm going to also introduce N to denote the number of features we have here, and so N is equal to 2, because we have 2 features, X1 and X2, for each movie. With these features, we have, for example, that the features for movie 1, that is the movie Love at Last, would be 0.9, 0, and the features for the third movie, Cute Puppies of Love, would be 0.99 and 0. And let's start by taking a look at how we might make predictions for Alice's movie ratings. So for user 1, that is Alice, let's say we predict the rating for movie I as W dot X of feature I plus B. So this is just a lot like linear regression. For example, if we end up choosing the parameter W1 equal 5, 0, and say B1 is equal to 0, then the prediction for movie 3, where the features are 0.99.
So really we're learning sort of weights for each user, and then we're learning for each item as well. So that becomes quite large matrices, I guess, if you increase the number of users and items. And how do you do when you introduce a new item when you don't know anything, I guess? Because in this scenario here, we are sort of learning the embedding layer. So what happens when we introduce a new movie that we don't have? I guess we would just I guess we just add one randomly initialized or something to the embedding, sort of a new row, and then we try to learn about it. But that way we have to learn from scratch every time, sort of for a new movie. I guess that's the only way to do it, though. Just sort of thinking when we get it running, if we would build like a recommender system for movies, how would it look like if it's deployed? That seems challenging, but I guess we won't have to worry about that. All right, so I guess they show here that using this type of framework with neural network, it can be generalized matrix factorization. Welcome to the team, Himanshu. Thanks for becoming a member. All right, let's see. Oh, okay, so here we go. Okay, so this is the generalized fusion of GMF. Okay, I don't really understand this, but I guess we have some user here. We send it into two different. Oh, okay, so you could maybe use a combination of some sort. You could still use the matrix factorization and the user vector that we get from embedding, maybe, and then you would concatenate it. So then it would have information about the sort of traditional method and as well from the neural network. I'm just thinking out loud. I'm guessing. Okay, I don't know how this works, so I'm just guessing, but that's my thought. Yeah, thanks for saying that. I was trying to get with recommender system. I figured the problem is kind of the cold start. Yeah, I wonder how to solve that. I guess you could. Yeah, you need to have some prior info about the users in some way, and try to build sort of a rudimentary system that can recommend based on that information, and then you sort of use the ratings to make an improved system all the time. Because you need to have something working in the beginning, otherwise the users will just leave, right? All right, and there seems to be a bunch of different methods, and they tried on some data sets. All right, I guess it improves well. It performs well because it's a popular paper, so yeah. All right, well, it seems like a very simple approach, really. If what my guess is here is correct, obviously I would need to go through it in more detail to know, but that seems to be my idea. I would like to know how this matrix factorization works on an intuitive level. Right now, it's not super clear.
And 0.
Himanshu asks, I want to develop an app which generates the emoji of a person as soon as he or she looks into the camera. I want to start with Dolly. Can you please suggest something? I would probably play around with like stable diffusion or something, and do some image-to-image conversion of some kind, and then see if you can just sort of prompt it to do it, or if you could sort of take stable diffusion or something and then fine-tune it. Maybe that would be pretty cool. But then you would need to have a data set for that, which might be difficult. I don't know how you, like, how do you generate an emoji of a person? How do you get labels for that? It seems to me that you would need to use, like, as you say, DALL-E or Stable Diffusion or something, and then you just use prompt engineering to do an image-to-image conversion. That would probably be my start idea.
Row, which is just copied from here. First feature is 0.99, second feature is 0. Our prediction would be w.x3 plus b equals 0.99 times 5 plus 0 times 0, which turns out to be equal to 4.95. And this rating seems pretty plausible. It looks like Alice has given high ratings to Love at Last and Romance Forever, to two highly romantic movies, but given low ratings to the action movies, Non-Stop Car Chases and Swords vs. Karate. So if we look at Cute Puppies of Love, well, predicting that she might rate that 4.95 seems quite plausible. And so these parameters, W and B for Alice, seems like a reasonable model for predicting her movie ratings. Just to add a little bit of notation, because we have not just one user, but multiple users, or really NU equals 4 users, I'm going to add a superscript 1 here to denote that this is the parameter W1 for user 1, and add a superscript 1 there as well. And similarly here and here as well, so that we would actually have different parameters for each of the 4 users in our dataset. And more generally, in this model, we can, for user J, not just user 1 now, we can predict user J's rating for movie I as Wj.product xi plus bj. So here, the parameters Wj and bj are the parameters used to predict user J's rating for movie I, which is a function of xi, which is the features of movie I. And this is a lot like linear regression, except that we're fitting a different linear regression model for each of the 4 users in the dataset. So let's take a look at how we can formulate the cost function for this algorithm. As a reminder, our notation is that Rij is equal to 1 if user J has rated movie I, or 0 otherwise. And Yij is the rating given by user J on movie I. And on the previous slide, we defined Wj, Bj as the parameters for user J, and Xi as the feature vector for movie I. So the model we have is for user J and movie I, predict the rating to be Wj.product xi plus bj. I'm going to introduce just one new piece of notation, which is I'm going to use mj to denote the number of movies rated by user J. So if a user has rated 4 movies, then mj would be equal to 4. And if a user has rated 3 movies, then mj would be equal to 3. So what we like to do is to learn the parameters wj and bj given the data that we have. That is, given the ratings a user has given of a set of movies. So the algorithm we're going to use is very similar to linear regression. So let's write out the cost function for learning the parameters wj and bj for a given user j. And let's just focus on one user, on user j for now. I'm going to use the mean squared error criteria. So the cost will be the prediction, which is wj.xi plus bj, minus the actual rating that the user had given, so minus yi observed. Sum of all mj's, then overfitting user j down, and sum it over users, which to make these predictions.
All right, so what's the assumption here? Let's see. We assume that we have a vector for each movie. That's xi, right? So I mean, we don't Like, we don't have this usually, right? So we would have to learn this as well somehow. All right, let's see.
In the last video, you saw how if you have features for each movie, such as features X1 and X2, that tell you how much is this a romance movie and how much is this an action movie, then you could use basically linear regression to learn to predict movie ratings. But what if you don't have those features, X1 and X2? Let's take a look at how you can learn or come up with those features.
Fucking right on. Wait, we have to watch that again. That was exactly what I just said.
In the last video, you saw how if you have features for each movie, such as features X1 and X2, that tell you how much is this a romance movie and how much is this an action movie, then you could use basically linear regression to learn to predict movie ratings. But what if you don't have those features?
Boom.
X1 and X2. Let's take a look at how you can learn or come up with those features, X1 and X2, from the data. So here's the data that we had before, but what if instead of having these numbers for X1 and X2, we didn't know in advance what the values of the features X1 and X2 are. So I'm going to replace them with question marks over here. Now, just for the purposes of illustration, let's say we had somehow already learned parameters for the 4 users. So let's say that we learned parameters W1 equals 5 and 0 and B1 equals 0 for user 1. W2 is also 5, 0. B2 is 0. W3 is 0, 5. B3 is 0 and for user 4, W4 is also 0, 5 and B4 is equal to 0. We'll worry later about how we might have come up with these parameters W and B, but let's say we have them already. And as a reminder, to predict user J's rating on movie I, we're going to use Wj dot product the features of Xi plus B. Additional movies.
So what is he doing now? He's sort of doing the opposite. We fix the weight and the bias, and then we come up with
close
X.
to what was actually the rating. It is squared error as usual. So if the predicted rating by
instead.
user J.
So we learned in the previous video, he wanted to learn the weight. If we're given the weight, we can learn
on movie I is given by this. So that top, where do you get those parameters from?
I'm sure you can do that.
Now,
all right, so you have one way to learn the weights and the biases, and you have another to learn the X.
It turns out that if we put these two together, this regularization term from learning the parameters W and B, and put that here, and take the regularization term from learning the features X and put them here, and this ends up being our overall cost function for learning W, B, and X. And it turns out that if you minimize this cost function as a function of W and B as well as X, then this algorithm actually works.
So you backpropagate and update all of these 3? That seems a bit different than what we usually, because we're sort of, I wonder if you do them in separate steps maybe, or do you do them in the same step?
Here's what I mean. If we had 3 users and 2 movies, and if you have ratings for these 4 movies, but not those 2, over here it does is it sums over all the users. And for user 1, it has determined the cost function for this. For user 2, it has determined the cost function for these. For user 3, it has determined the cost function for this. So we're summing over users first, and then having one term for each movie where there is a rating. But an alternative way to carry out the summation is to first look at movie 1. That's what this summation here does. And then to include all the users that rated movie 1, and then look at movie 2, and have a term for all the users that had rated movie 2. And you see that in both cases, we're just summing over these 4 pairs where the user had rated the corresponding movie. So that's why this summation on top and this summation here, there are two ways of summing over all of the pairs where the user had rated the movie. So how do you minimize this cost function as a function of W, B, and X? One thing you could do is to use gradient descent. So in course 1, when we learned about linear regression, this is the gradient descent algorithm you had seen, where we had a cost function J, which is a function formally to denote the feature U, and B, and X is also C as well as X. So and X is also a parameter. And then finally, to learn the values of X, we also will update X as X.
It feels strange to do it this way, but yeah, I guess it's not that too different from this approach, right? Because I mean, we're learning the embedding for the we're learning two embeddings here, so I mean, we are learning both at the same time, and hopefully the system can figure out how it should make the embeddings so that they're useful in the most general setting. Because I guess we have many of these items for many different users, but the users are different. So it might learn that this one should be it should, I mean, it should, I guess, figure it out. But yeah, it's interesting that you update all of them, those three, that none of them are fixed. It just seems a little bit different. And this is, I'm also curious about this. For collaborative filtering versus content-based filtering, I mean, it seems to me that collaborative filtering is most popular, but content-based filtering might be interesting as well.
In this video, we'll start to develop a second type of recommender system called a content-based filtering algorithm. To get started, let's compare.
I'm also interested, like, since he did a recommender system, if we can look at his GitHub. By the way, is the stream lagging in some way? Because I watched the previous stream I did, and the audio was sort of lagging, and the video was as well. It's like right now. Yeah, there's something wrong with the camera, I think. But let me know if it's lagging in some way. I wonder if you put the code on this. I guess he didn't, maybe. All right, so he makes a custom class for the movie. We have users, movies, and ratings. We get item. We just and then he makes a model. He makes a user embedding and a movie embedding, and then a simple linear out. Okay, so this is actually concatenation, right? Because I'm assuming he's doing something similar to this. And here we are putting them together. We're running through an embedding layer for each. And then we run through multiple layers, I guess. And then here we just run it through a linear one. So we get all of those three. He runs through the embeddings. He concatenates them. He runs it if ratings. Oh, okay. I mean, I guess we would only send forward. I mean, my idea here is we just output this, the score here, and then we compute the loss outside. But I guess maybe he computes it inside here. Okay. And then what? So he computes the loss. So he wants to have the forward general, I guess. He wants to have it so that you can compute the ratings, and you can just run forward if you don't have the ratings, and you'll get a predicted rating. Monitor metric. All right, so he has a metrics. Metrics. I mean, this is super simple, right? This is like ridiculously simple, but it's pretty cool if it works. I wonder what like state of the art recommender systems are. Like, um, well, okay. What's this? Okay, GHRS. Kind of curious what state of the art is, but I don't think we're gonna uh, do anything of that. Just sort of curious how it looks like, if it's different. I mean, it must be, but yeah, maybe we can try this though. I think this seems pretty interesting. Let's see. Okay, so should we maybe go through the paper a little bit more detail? What do you guys think? What do you guys think? Is there anyone here? Try a graph neural network approach. That would actually be pretty interesting. Yeah, maybe that would be interesting. Maybe it's a good idea probably to start with this, but maybe that the next iteration would be to find some graph neural network approach. I think that would be pretty cool. And it feels like this is a graph. I mean, this problem is in the graph domain, so I feel like graph neural networks are the way to go here, right? And I guess it would be is that so you would have, yeah, what's the graph here? It's you have users as nodes maybe, and then you have I don't know how you would actually, how would you model it though? How would you represent it as a graph? It seems like there's a simple one. A bipartite graph. Okay, so you would have, okay, both are nodes, and you would have users on the left side and the movies on the right side, and then you would connect a particular users which with the nodes it has reviewed, and then the edge would maybe be the rating of the user for that particular movie. That's a pretty that seems pretty solid approach. I'm feeling kind of lazy to go through this, but I feel like I should go through it in more detail because there might be something that I'm missing. And I would also like to understand the difference a little bit better.
Contrast the collaborative filtering approach that we've been looking at so far with this new content-based filtering approach. Let's take a look. With collaborative filtering, the general approach is that we would recommend items to you based on ratings of users who gave similar ratings as you. So we have some number of users give some ratings for some items, and the algorithm figures out how to use that to recommend new items to you. In contrast, content-based filtering takes a different approach to deciding what to recommend to you. A content-based filtering algorithm will recommend items to you based on the features of users and features of the items to find a good match. In other words, it requires having some features of each user as well as some features of each item, and it uses those features to try to decide which items and users might be a good match for each other. With a content-based filtering algorithm, you still have data where users have rated some items. So with content-based filtering, we'll continue to use Rij to denote whether or not user J has rated item I, and we'll continue to use Yij to denote the rating that user J has given item I, if it's defined. But the key to content-based...
So the idea of content-based is that we have features already of the items in some way. So we have some kind of representation of the movie that's not related to just a learned representation.
Filtering is that we'll be able to make
perhaps
good use of features of the user and of the items to find better matches than potentially a pure collaborative filtering approach might be able to. Let's take a look at how this works. In the case of movie recommendations, here are some examples of features. You may know the age of the user, or you may have the gender of the user. So this could be a one-hot feature, similar to what you saw when we were talking about decision trees, where you could have a one-hot.
Okay, so we have some type, okay. All right, so we get some type of features of the movie and the user, okay. I mean, this might... Maybe this is a good idea to start with as well. Maybe you would want to build, because usually you can get some type of user features, right? And you can get some type of movie features. Maybe they're not that great, but maybe you can start with that, and maybe that can solve the cold start problem. Yeah. Don't forget to subscribe, where all your gradients will vanish, by the way. It's a warning. I'm just telling you.
Feature with 3 values based on whether the user's self-identified gender is male.
That's how I got all my subscribers, by threatening them with the truth.
Male or female or unknown, and you may know the country of the user. So if there are about 200 countries in the world, then this would be a one hot feature with about 200 possible values. You can also look at past behaviors of the user to construct this feature vector. For example, if you look at the top 1,000 movies in your catalog, you might construct 1,000 features that tells you of the 1,000 most...
I mean, yeah, I guess like one thing you could do is recommend the most popular ones or whatever. That's probably how Netflix does it, right? Like it's like, these movies are pretty good. Most people think these are good if they don't know anything about the user. That's probably how you would want to do it. Like, if you don't have anything about the user, you would maybe want to, here's the highest rated movies on IMDb. But maybe you also want them to be relevant, not just like 50 years old movies or something. But I was also thinking, like, in many cases, you could maybe just build a very rudimentary one. If you have but then you would, you would still need to have the rating, right? Even if you have these features.
Popular.
So this seems a bit less interesting than collaborative filtering to me, because here in the collaborative filtering, you're actually asking the network to learn the features itself, instead of just saying, these are the important ones, because then we're in sort of inputting our own bias, right, of what's important for the rating, instead of it learning it implicitly. But maybe some of these information might not be, it might not be possible to capture it, right, from the data we're giving it in the collaborative filtering approach. But you could also, you could concatenate the info before you run it through. So you could do, it doesn't seem to me that you need to separate them. You could perhaps have some features that you collect, and then you add those to the features that the neural network learns by itself. I don't know if that's correct or not, but that's
movies in the world. Which of these has the user watched? And in fact, you can also take ratings the user might have already given in order to construct new features. So it turns out that if you have a set of movies, and if you know what genre each movie is in, then the average rating per genre that the user has given. So of all the romance movies that the user has rated, what was the average rating? Of all features for each movie or for each item, such as again, there's nothing task is product of X numbers from which multiplies these in size. Number of users give ratings of a network rating of this user on that movie as VU dot product with VM. Notice that the user network and the movie network
and a movie
can hypothetically have different numbers of hidden layers and different numbers of units per hidden layer. Only the probability, and this gives us YIG movie net, so that the distance between this approach to a very
So it's V in this case. You have the user information. You run it through a linear layer. You get some type of new one, a 32 output vector, and similarly for that particular movie. So you get, you can learn some complex relationship between those. Then you get to 32, and then you just do a dot product of those, and that's the score, I guess. And then you do that. That's prediction. Okay, cool. And then you can find similar by doing a L2 distance to the other ones. That seems pretty I guess that's a solid approach. All right, we have an idea now. I feel like we have an idea of how this works, how content is different from collaborative, right? I'm not saying we got a good idea, but after an hour, we have some idea. And then what is probably needed now is to get a much better understanding of the paper, because in this case, it seems the paper is pretty clear, at least in how we implement it, based on how we could see that it's exactly like that from Abhishek's video. So maybe we can just try to build our own, and we can, we can see if it works, right? We got some results they got here, and we can try it out. We can see what they get. So I'm curious how they actually made with different layers. Yeah, this is what I'm curious about. So they here say that just a single one was pretty bad, I guess. So 4 layers is probably the best. And then, all right, and they say number of negatives. Anai says, I think item-based collaborative filtering is one of the best ways to build a recommendation engine, but it is prone to cold start, sparsity, and gray sheep problem. Why don't you try it? What's the difference between, so you have item-based collaborative, what's the What are the other ones? Okay, so you have user-based. What's the difference? Because he didn't, I mean, the one, is this one an item-based, I guess? User-based collaborative filtering. Okay, so let's see. Items recommendation, user-based collaborative filtering. Items recommendations for user is calculated depending on that items rating by other similar users. All right, so we look at what did other users rate this particular movie, and then we use that. I'm just curious how, so is this an item based in general? Because I don't know if we should read the paper probably. They probably should mention it. Although some recent work has employed deep learning for recommendation, they primarily use it to model auxiliary information such as textual descriptions of items and acoustic features of music. When it comes to model the key factor in collaborative filtering, the interaction between user and item features. Okay, that's not about that. Introduction. Okay. All right, so wait, so we go, if we have many users, we have many ratings for a movie from many users, then we can use the information of how that user has rated other movies, and we can see sort of what users are similar to this particular one based on the movies that they've watched in general, and then we can use that as a prediction. But this is, we're looking at a particular movie and we're trying to find what movies are sort of the closest based on a single user's prediction. That seems to me to be, I mean, so we're only using information about Okay, so I guess I see that there's a difference between them. I wonder what this one is then. Is it only in the prediction step, maybe, how it's different? Like, how do we, when we're actually recommending stuff after we've trained it, that differs the item based and the user based, maybe? Because I can't see. Yeah, I guess it's, for the approach here, it seems to be the same. All right, let's start just coding something. Or actually create and neural collaborative NCF. Let's just call it NCF. No, let's see what it was. tmux create session. tmux new session NCF recommender. All right, cool. We can probably use torch stable and yeah, by the way, I finished the let's see. I've completed the lightning tutorial series, by the way, and I will start uploading it next week probably. And it's basically a 10, I'll show you. It's like a 10 series, 10 video series. So like this are the videos I created. So I go through like why I use lightning. I'm pretty excited for this because I think it's going to be a simple way to learn about it, hopefully. And so it's like introducing lightning, the lightning module, the trainer, and we're sort of integrating one lightning feature at a time. And then in the end, we show like multi-GPU training, profiler, TensorBoard integration, callbacks, and so on. And so they're kind of to the point and concise. So like 10 minutes each. And I hope they're going to be useful for people that are going to want to learn about lightning. Yeah, just wanted to tell you guys about that. I'll probably release it, I don't know, early next week probably. Let's go, maybe it's like more advanced. I don't know where to put this. My structure on this GitHub, it needs to reach, like, I've done basics, CNN architectures. This one should not be there. We can probably remove that. So we have others. What is in others? Default setups. Okay, I have no idea. So I guess this is in, I don't know, maybe we should make a new like recommender systems. All right, so let's try to code this. I mean, we need to get data first, right? Oh, so let's try to download some data. Let's see. movie lens. Movie lens dataset, download. I just want like a small one, right? We don't want the big one. We just want to try it out. This one is probably good. Copy link address. And I guess that's it. These files contain 1 million anonymous rating, approximately 3,900 movies made by 6,000 users. All right. And how do you download? I guess you do this. No. I'm kind of new to this. I'm not that comfortable yet. Let's see. Movie lens.zip maybe. Okay, wait. How do you do that? Do download. Oh, that was not okay. Wait, we'll go back. All right, so here we have it. Let's unzip data.zip and then move. And there we have it. I don't know, movies.that. All right, so we have a bunch of different movies. We also have which one it's a comedy. All right, cool. And then we have ratings. Oh, this is huge, right? So this is the rating. This is so this is the user ID maybe. And that user rated this movie or something, or this. I'm not really sure. We'll load it as a CSV and we'll check. For some reason, I don't know why I'm not getting the chat thing. If I go live. Go here. Oh, it's higher than recommended. Depending on the number of users, your approach should pivot. General approach for a smaller user base is to go item-based, but if you have a large user base, then user-based collaborative filtering is recommended. All right, that's good to know. Thanks for the info. So let's just start, I guess, with checking the data. So we'll go back, we'll open up this. Let's see if we can. What was it called? Rating. What does this mean though? Is this like should be some type of explanation, I feel like. Alright, we have ratings files. Users range between 1 and 6,000. Movie IDs range between 1 and 4,000. So we have 4,000. Do we have 4,000 movies? Okay, 4,000 movies and 6,000. Movie IDs range between 1 and 4,000. Rating is made on a 5-star scale. Timestamp is represented in second since the epoch as returned by time. Timestamp. Alright, each user has at least 20 ratings. Alright, and then we have users. We have the age. We have occupation. All right, and then we have genres, and it's split by 2. All right, so I guess maybe Copilot was right here then. I mean, we don't have a header in this case. We separate with these. We have the, I mean, Copilot already knows it's such a common data set. Okay, I mean, that's pretty good though. Nope. Okay. Okay, here we go. Created. All right, so we have user ID, movie ID, rating, and we set the names of them. All right, I mean that's pretty good. We can load the. Can you build something which is not just a classification or regression problem in recommendation? I have many people just training a model which are just another classification or regression system. Well, sure. I mean, like the goal here is to make something that works, right? Something that you can, like I'm learning about this now because I'm gonna use it in a project, and so my goal is to like learn what actually works. But so I guess this is just the starting point, right? This is where you would probably start building a recommender system, and then you would make it more advanced. I think it was Anai who said that we could explore a graph approach. I think that would be interesting, but I'm not sure like how, what would you recommend? Like how, is there a particular paper, a particular approach? What do you think? As I learn more about this, we can sort of make a more complex model, a more advanced model that works better. All right, load the, let's see, we want to load this. For example, something like based on user attributes and activities. Transformers perform strong based on papers. Yeah, I mean that feels given. I feel like all types of problems nowadays, you're like, what should I use? Well, transformer in some way. So maybe that's the maybe that would be the next step. Maybe go from a sort of a fully connected to a transformer of some kind. But I mean, we have to start somewhere, right? I don't know about this. I'm just learning about it, so I can't do something. All right, so let's see. We did DF ratings. Let's do DF. What was it? User? No. I need to make a remapping so that you can force Copilot to make a suggestion. Like right now, I only have it. I guess it makes a completion if it thinks it's correct. But now it's sort of, you have to now sort of prompt it, and then sometimes it actually auto-completes. But you know, it seems like there's a I don't know what it is for this one, but there's a particular mapping you can make so you can sort of force it to make a suggestion. All right, let's do this. Data, it's users. I guess it's the same separation. Header none. Let's see what names it was. This is the user. The user is user ID. Gender, age, occupation, zip code. So we have let's see, ratings, movies, users. Let's return them. Movie ID titles and genres. Movie ID title and genres. UTF can't decode by 0. Alright, so that one worked. Guess it's just this one then. Let's see. Can you do private lessons in deep learning? Some people have asked me about that. I don't know. I just don't feel it would be too helpful. Maybe it depends on what. I mean, yeah, I'm not sure about that. It's not clear to me what I could what the value I would offer, but I'm not against it. Akash asks, can you keep these videos on your channel? Yeah, I'll keep them. Anais, steps involve data collection and cleaning, transform the data into a matrix. This matrix should have users as row and items as columns, with cells filled with user item interactions. Perform matrix factorization techniques like SVD or any to reduce data dimensionality, identify latent features that describe the user item interactions. Let's see. So Anai, what are you describing here? Is that different from what we're trying to do from the neurocollaborative paper? I mean, is these are the steps you're saying for that paper, or is this the general? Because they didn't use SVD, right? Their idea is that I guess the neural network can learn the decomposition by itself. But maybe that's a better idea, to start with using SVD. Yeah, the general approach. Okay. Yeah. Maybe it would be smarter to start with some matrix factorization method and then do the neural network approach. That would probably be a smarter way of doing it. But it should probably not be that difficult, right? If we get this working, then we can probably change it and try to show the general steps. But this is good. So that we're on step 1, right? We want to clean. Oh, well, we already have the data. We just want to load it. Transform the data into a matrix. This doesn't work to load it like this. It was the users, right? One, two, three, four, five. Oh, this is not right. That one had 5 though, so this is movies. Movies. Let's see this. The movies. Oh, that was okay. Users, right? Movies. Okay, that's 3 though. Should we try to use that decoding thing? Okay. All right, so we have that movie ID, and then the title and the genres. All right, and we also have other stuff. I mean, we're not going to use all of that, so let's just create. What do we need? Import torch. What do you guys think about this, by the way? Do you do import torch.nn as nn, or do you do from torch import nn? Because I've usually done this, but then someone commented and said that this is very ugly and you should do that instead. So now I've started doing it this way. I don't know, I don't feel it matters too much, but just curious. All right, so what do we have? We have the actual just data frames now. We can create a class. Okay. Let's see. So we want to do, we got movie lens data. We are loading the files. We want to have a link. What's the actual link? So how did it look like again? So we have ratings, that would be this one. Oh, this is a problem I need to solve with NeoVim. If I use the like black for, I don't know what the problem is. Like if I use black formatter inside like this and I just run it, then something's wrong with the LSP, so I need to sort of redo it. But if I run it outside like this, then everything is fine. Yeah, I need to fix that. And I also need to do a remapping of Copilot because it's not always working now. Okay, so the ratings has 1 million, right? And I guess that's what we want to take, right? So what do we actually want? We want to have the user ID, the movie ID, the rating. I mean, those are the only 3 things we want, right? We don't actually need to load these 2. That would be if we are doing content based, I guess. Am I correct about that? It seems like if we're doing the collaborative filtering approach, all we need are these, because we're gonna learn. These are essentially the embeddings that sort of someone has just written down for the movies, and these are for each user. So we can either do a content-based approach or collaborative filtering here. So let's just try the collaborative filtering one. Is there a particular reason you switched to Vim? I don't know. I used VS Code, but I didn't. It's mostly now when I've started using SSH more, and sort of working on a remote server. I think VS Code works as well. I just like the simplicity of using the terminal. But I haven't really made my mind up yet. I've only been using it for, I guess, 2 weeks. So but there are some nice stuff. Like, I like that if I shut down the server like this, and then I re-enter SSH, and then I attach back. So wait, if I do tmux ls attach ncf recommender. Oh wait. Okay, wait. How did you do this? Oh no. Okay, let's see. Wait. You should be able to do this. There we go. All right, so that's how you do it. So if I just like shut down the machine, let's say I SSH back, I can just run tmux attach session back, and I'm sort of back directly to my workflow, and it's just super fast, super convenient. I like that about it. What are your thoughts on PyCharm? I think VS Code, PyCharm, I don't think it matters. So we're just gonna use that. I mean, if we have an index, we're gonna get those 3 and that's it, right? So, I mean, this is all, I guess. We're not gonna be using the movies here and stuff, so. All right, so what's next? I mean, we want to build like a simple the developer chakra flow more smoothly. That'll be my go-to. Why do you use Vim to make chakra flow? Let's see. Let's ask Copilot to do this. Create a simple neural network with 3 layers or 1 layer. Let's see if it does the right thing. So we have end users and movies. We have embeddings. Then we multiply by 2 here. We will go to 1. Let's see. We do a forward of the user in the movie. We concatenate them, and then we do a linear. You know, I watched someone recently actually coding in Notepad++, and I just felt like how can you use that? Like, how does, I mean, when I got started, I used I used I used to watch Sentex a lot when I got started. He was kind of the reason I started coding. Before I started studying at university and stuff, I was like, wow, this Python thing seems really cool. Like, programming seems cool. You can build stuff. And he was always using the Python IDE, like the built-in. So, and he was like, yeah, you don't need anything fancy. It works. And like, I used that for a long time, and I never even installed PyCharm or anything. You fucking troll. Notepad++ in Windows and get it on Ubuntu. Yeah, I mean, as long as it works. I don't know, I feel like it's worth spending the time to learn something. Yeah. But not everybody agrees. What's next? We need to split it also on training and val, obviously. Alright, so what we're doing, we're getting user, rating, output. This should be the rating, right? Output. And then we're doing loss to backwards, and we need to initialize loss. Should be MSC loss maybe. And then hello. Okay. Alright, this is obviously not perfect structure, but hopefully this works. Can you make some courses for members building a computer vision app? One thing I would really like to get into more is building. I think it would be really cool to build some open source, just useful, I don't know, like machine learning projects and just deploy it to build a nice website and people can use it. Like just yesterday, I was like, I wanted to take a picture or an image with a green screen, and I wanted to remove the background. And there are tons of websites, but they're all annoying. Like all of them, they want to sell you on this, like pay $10 a month so you can get this background and stuff. And it's just, you get this watermark on it, and it's just annoying. It would be nice to just build free sort of, I mean, it costs to deploy these things, right? It's like, I understand, but it shouldn't be that expensive. If you just want to break even, I don't think it should be. Face is blurred. Alright, let's see. Yeah, there's a. Let's see if I can move this. Maybe it will be better. Let's see. Alright, maybe this is better. Yeah, deploying model MMO is a real hassle. Yeah, like I that's what I want to learn though. I feel like we need to learn the how to deploy to actually make something useful. And I played around a bit with TorchServe. And I got it working, and I have my own I can use my own server at home, and I can just sort of, my idea is to deploy the website on DigitalOcean or whatever, just some where you can make a droplet somewhere, and then you have the website on that one, but you have a server, the GPU sort of with GPU enabled, and then you can just run quick inference depending on what you need, right? Maybe for some you can just quantize your model and then run on the CPU, but I feel like that would be my sort of thing I would like to do. Maybe we can do that on stream as well. We can sort of come up with some type of project, and then maybe that would be like some, and the idea is then that yeah, either we put ads on the website and then mention specifically like all of this will go back to either funding a big like model or just for hosting the model. Because I don't care about like all of the other ones. It's annoying because they want to make a profit, right? It's a company, but it's not too difficult to build those projects. If we can just get it deployed, then it can be up and running. I don't know, I think that would be pretty cool. All right, let's see if we can run this. I feel like I got a better understanding of it. There's a lot missing though for me to. Recommender system is a sort of a large area. But let's see if we can run it. I used Google Sites to host Google Cloud to serve the model. It was pretty good since everything is not so wait, Google Sites to host. But how much does it cost to host on Google Cloud to serve it? Because if you have I mean, everything I've sort of checked is pretty expensive if you want a GPU enabled. That's why I've sort of, in my mind, I want to have my own, build just my own server, and I can host it locally instead. But yeah, otherwise, I mean, you could host it. I tried hosting on Amazon, and hosting on Amazon is or AVS is fine if you do CPU inference. It seems pretty cheap. For career growth in deep learning, you should not focus on a particular brand such as NLP or be more like a jack of all trades. I like Andrew Ng's idea on this. If you look at, I think it's CS229 lecture videos, he kind of talks about career advice, and his idea is that you should be T-shaped. So you should have an understanding of many areas, but you should be specialized and really knowledgeable about one. So I think that's what I think. Is that an yeah, it's Copilot. I know that a lot of people don't like Copilot, but personally I think it's great. Granted, my kernel is only 28 megabytes. Yeah, it I don't know what's the cost of this, like monthly. How much do you pay for? Is it only CPU inference or GPU inference? All of the, oh, okay, right, okay. Yeah, that's interesting. I remember I wanted to do like an app, and I built it using Flutter, and then I did sort of on-edge deployment where all of the compute is made on the phone. But if you look at, I mean, for example, Hey Google or whatever, all of them use like all of them needs an internet connection to run, right? Nothing is done on the device, and I think it's because if you scale it, you can't have that large of models running on client side. So to ensure that it actually works and you can run large models, you need to have a large server somewhere. But you can probably build a lot of projects on client side if you do it in a smart way. Which area would you recommend to become an expert in? I don't know. I don't know, whatever you're interested in. I mean, yeah, I think what you're curious and interested in, that's what you should do. And you should build projects in that area. I personally, honestly, I know there's a lot of people that do courses, and many of them actually earn a good amount of money. I don't like the idea of having paid courses. I don't know, I've never liked that idea. I think everything should be, I just like uploading videos for, like, that's why I'm also wanting to build open source sort of websites that people can just use that aren't annoying. I just think things should be accessible. You also have to make a profit, or you have to have it maintained, right, in some way, and that's where you need to make a profit. And so I get it too, but it's not a compromise I want to make. All right, let's see what happened here. Kubla's state not initialized? What? Okay, does anyone know what's going on here? F linear. Why is it F linear? This is weird. So we're probably doing some indexing error probably. Or we don't have, I guess you need to do +1 maybe? What's the number of users we have? Let's do. just do len users, num users. See if that's the issue. It looks like that's the issue, but not sure. Yeah, I think so, yeah. Hopefully we can do that in the future as well. As I learn more about DevOps and sort of deploying stuff, I want to make that a part of my channel as well, building sort of open source. And then I can use either, you know, if I get some videos sponsored through YouTube or just ad revenue, I can use that to sort of be able to build projects that are actually accessible and free and not annoying like most are. I mean, if you want to, like, for example, one project I wanted to make, I made it a long time ago to a watermark removal, but I used a simple, you know, GAN approach, and now you can easily just use sort of stable diffusion or something, and you can remove watermarks. And there are many, you can build a website for that. New logo too. Where do you see that? Wait, did you? Oh, there. Yeah. All right. No, it's I lost my train of thought now. Anyways, if you have the resources, make that is capture a particular object from camera and make the object look animated. Thinking of I think this is I want to create, I'm in the process of creating a company, and I wanted to make a logo for it, or actually Midjourney made the logo. Put more ads. I think honestly ads doesn't pay that much. I think if one wants to build really nice open source, like if we're gonna be able to sustain it, I think sponsorships is probably the way to go, or something like that, or just like I have now, maybe in the long term, maybe members would like channel members and so on. I'm not sure. We'll see how it goes. But I feel like I have enough now to just sort of, we can build some interesting projects and to host them locally. Like a droplet doesn't cost anything to host a website, it's just a couple of bucks a month, and then the GPU inference is what's expensive. But if you build a server locally, and like I have now, and then I don't think it should be that expensive. I mean, it's basically like it's electricity cost. But maybe I'm naive, I don't know. All right, so wait. What's wrong? What's wrong? So it wasn't the linear forward call itself, that linear? Okay. N factors 50. I wonder why. I wugga why. I wugga why. I wugga why. I wugga. I wugga why why. Okay, x dot shape. Come on. 64 and 100. Okay, and then you concatenate. You should be able to run that. Model.toDevice. So it's here that we get the error, so we can't run it, I guess. Index out of range. So that's a tip, by the way. If you get wrong, if you're getting sort of weird errors, one thing you can do is just change the device to the CPU and you'll get much better errors. That's just a tip. I added memberships like a week ago or something. Majored in maths. My undergraduate is in maths, but I'm sort of like I have taken some math courses. Like I haven't taken theoretical mathematics. It's sort of just applied maths, optimization, and so on. And then I've in my master's degree, which I'm doing now, is in data science specifically. But I'm mostly interested in machine learning and that stuff, which is a combination of programming and maths and so on. So I would say I've sort of learned exactly what I need to be good at machine learning. This is for the people making less people using it than people using. Thanks for becoming a member, Daniel. Welcome to the team. Original company is RMSE. Yeah, we can add that metric probably. Post the error in chat. Let's see. So we got the error though. Let's see. We should be able to get this hopefully to work. If we get forward call towards embedding. Okay, so it's in the embedding, I guess. $7,000 and $3,800. Okay, but we have 3,834 on the movie ID. Okay, I mean that's not correct. Let's print the movies here. I should get to use breakpoints in Vim. It would be a lot easier, I think. Okay. All right, so we get that there. What's the max then? Tiny ML. Through your code, I finally understand the details of YOLO. That's good. Thanks for the support. It's 3,900. Maybe we just got the wrong then. So let's see. It says here, yeah, 3,900 movies. I guess. I wonder why this is wrong then with the unique. I don't know. Maybe we should do that instead. Just num users is users.max and do it this way instead. And then maybe +1. Maybe that's good enough. All right, and then it's running at least, right? That's good. Did I remove something? No. What? User embedding. All right. Take care, Anai. Thanks for joining the stream. It was nice having you here. Thanks for the help. I think I'm gonna sign off as well pretty soon. It seems that we got a simple movie recommender to work. I mean, this is very simple. I think like next steps, like what would we want to do? Ideally, I would want to convert to Lightning code. Just because I've practiced it now, so we can to Lightning code. But I would like to add split to train val and add RMSC metric, and then maybe do prediction. And then like how it would look like in practice, user and item based collaborative filtering. What else would we like to do? After that, try new modeling approach. Maybe try do simple content based filtering. We could also, let's see, what could we else do? I mean, try another modeling approach. Read papers and see what's out there. All right, I mean, those are probably the next steps, but we got something running, and I mean, something simple, and it seems to be okay. Have you thought of using PyTorch Lightning? Yeah, I just finished a series on PyTorch Lightning. I'm gonna be uploading it starting next week. It's 10 videos. I think it's gonna be, I hope they're gonna be helpful to people. Even at my university, majority of us are Chinese. At my university, like, I think it's definitely a lot of international students from all over the place. But there's a lot of Swedes as well. I mean, probably like maybe 70%, I'm just guessing, but like maybe 60-70% are Swedish, and then where are you sharing this? GitHub. I'm gonna upload it to GitHub. Yeah, I'm gonna the repository where I have all the code. I don't know if I'm gonna do it now though, because I want to clean this up a bit, and I'll probably continue on this in another stream, maybe tomorrow. Have you checked out Mosaic ML Composer? Is that's kind of like Lightning, right? It's just another framework. I just started a project PyTorch Lightning like code. Yeah, I agree. Although, I mean, I like just that you can change the number of GPUs you train, easily change the precision, and I like having the structure that Lightning provides. It's a nice wrapper, and I feel like TensorFlow and Keras, it's kind of difficult to know the difference. I feel like in Lightning and PyTorch, the distinction is much clearer to me, and it's much clearer that you can sort of build Lightning on top of just your existing code and then just modify it slightly and then add more flexibility, because you still build on top of PyTorch in a much cleaner way, I feel like. Also, rendering the movies recommended in a clean UI. I mean, that would be pretty cool if we would actually build like a project for it, where you would have a user and it would recommend movies. Maybe this would be some type of future step. Yeah, good night. Nice that you joined the stream. What's the next big thing in ML? I'm hoping the next big thing will be an architecture shift. I feel like the transformer has been dominant for a long time, and it will be nice to see a new one take its place. I feel like if we are still using transformers in a couple of years, if we're still using transformers in 3 years, I feel like we have become a bit stagnant. But there's still many interesting applications that we can build. But if we're looking at sort of machine learning or AI, I feel like most interesting right now is self-supervised learning and coming up with new architectures. My friend who works in autonomous driving says everyone used TensorFlow. I don't think so. I mean, listening to people, for example, I listened to George Hutz on Lex Friedman, and he said life just became better when using PyTorch in production. And Tesla uses PyTorch as well. Everyone in the industry. Well, maybe it's the case. It's simple. Just yeah, yeah. I'm using the paper from today to recommend computer games. Yeah, I want to try Streamlit as well. I haven't. Your thoughts on Stable Diffusion? I mean, it's awesome. I want to do a project where we remove. I want to take my watermark removal project and just take it to the next level by using Stable Diffusion to remove the watermarks, and then we'll build a simple website where you can input image and you get back your image without the watermark, if it's legal to do that, we're gonna do it, and then people can use it however they want, and we'll basically delete Shutterstock forever. Yeah, but I haven't read the paper. When are you going to show Lightning module? Please show the class methods. So I'm gonna be uploading videos pretty soon on Lightning, and then we will go through like this. I'm gonna have tried to structure it in a nice way, so that first we use basically why should we use Lightning, because it's not clear to all people, and then basically introduce one functionality at a time. So we go the Lightning module, then we add the trainer. So the Lightning module is the train step, val step, test step, and so on, and getting the optimizer and so on. And then we use the trainer, we add metrics, we introduce the data module, then callbacks, logging, profiler, and multi-GPU training. And then I might do more advanced in the future as well. But that's sort of the basics of Lightning. No, that's on my to-do list. I just know for now the fusion models are not that clear. I mean, I know the each component, like clip and VAEs and so on, but how to put it together would be nice, and maybe that's something we could do on stream. I don't know. Silly question, why model calls forward? I mean, I don't know why they did it that way. They must have had some reason, but yeah, that's exactly what I do. We start with like very simple project that we've built before, and then we sort of try to convert it one step at a time. But this is just because the call method runs the forward. So if you look at the call method of an NN module, it runs model.forward. All right, guys, I will check out here, and I will I'll see, maybe we can continue tomorrow and complete and make it a little bit more general, and then actually see how we can use it. But this was a chill first step on understanding collaborative filtering. All right, guys, I'm gonna go make some dinner. Thanks for joining the stream, and hope you found it interesting. All right, guys, love you all. Oh, thanks for the donation, Clayton. I appreciate it. All right, love you guys. Bye bye.